Hello, Dr. Sergio. Can we begin? Are you ready?
Hello,
Hello.
Professor. Ready. Good
Okay.
afternoon.
Okay, good afternoon. Can you please begin?
Yes, I can start.
Okay, thank you.
Okay, thank you so much. You can see my presentation,
Yeah,
Professor?
yes, yes, it's fine.
Okay, thank you. So I can start. It's okay?
Yeah,
Okay, thank you. So thank you so much for the opportunity to present my work, the second one. Yesterday I present the first one for another location in Madeira Island. Thank you for your invitation, Professor. Thank you for all the participants that are in online mode. I'm Sérgio Lousada for the University of Madeira in Funchal, Portugal. I will present my work hydraulic planning in insular urban territories, the case of Madeira Island, Ribeira Brava. And I have divided my work into five big parts, a little bit introduction, material and methods, results, discussion, and some conclusions. Okay, in the left part of the slide, you can see a picture about Ribeira Brava, one of the 11 municipalities of Madeira Island in Portugal. So, introduction, how does climate change affect flood risks, urban and weather atmosphere, more energy for storms, coastal flooding, and more intensive downpours. So in the in past years, we have some problems with some climate change. So we need to achieve some technical measures and not only reports, but also make some infrastructures in Madeira to achieve and to obtain conditions for giving a good life for all inhabitants of Madeira. So we need to achieve some results, and I make this work in line to achieve some ideas, some measures that we can input in some mainstreams in different municipalities of Madeira. So, what are the flood reasons? Some introduction. You can see in the right part of my presentation, the slide, some pictures about the recent big problem that affect Madeira Island. Some from Funchal, that is the main municipality, the most important one, and the other ones from Ribeira Brava and São Vicente also in the down part of the slide. And this event occurred in February of 2010. So, what are the flood reasons? Heavy rainfall caused by natural weather events, insufficient forest, incorrect agricultural practices, inadequate design of drainage channels and structures, inadequate maintenance of drainage facilities, clogging of rubble brought by flood waters, and settle down of flood plains. So materials and methods, the area or study. The study is focused in Ribeira Brava at watershed. Is located in the southern slope of Madeira. You can see in the left part the Madeira Island map, and the blue part is the Ribeira Brava watershed. Okay, I put one picture about the conditions of the mainstream and the location of the Madeira Island to Lisbon and to other cities, Rabat and Casablanca. Okay, Madeira Island is in the middle of the Atlantic Ocean, so we are an island and we have some problems with climate change. So materials and methods. Next part, schematic of methodology. So we have six big steps to develop: literature review, watershed morphometric analysis, hydrological analysis, analysis of the drainage capacity of the river mount, detention basin sizing, and definition of the ruggedness coefficient. So, materials and methods, morphometric characterization of the watershed. We need to achieve different values of different parameters to make accurate characterization of the watershed, in this case of Ribeira Brava. Also, we need to obtain data about the last to 20 or 30 years of data of precipitation. And all this information is given by me by the civil engineering laboratory that are present in Madeira Island. They give me this information, which is when I can make the extrapolation of the precipitation for the next years. So I need this when, and with this data, I can obtain the peak flow and I can obtain the drainage capacity of the river mount of the mainstream of Ribeira Brava. And also, I can use two different methods, the Dutch method and the STAG method, to achieve what is the most correct to make the implementation of the detention basin sizing into mainstream. Also, I can make some modification in the ruggedness coefficient, that is the materials that are input in the walls of the main streams. We can use concrete, is the most correct to do. And also, this one is probably one of the best solutions because we have some limitations to make some modifications in the mainstream because the mainstream is already constructed and in its perimeter we have some streets and some buildings, so we have some limitations. We need to maintain every time the same height and the same height, so it's not possible to make some this type of modifications. Next one. So, like I have said in the last slide, we have to determine the area and some parameters, perimeter and length of the main weather course. With the help of the ArcGIS software, we obtain all these parameters, and with this one, we can make the correct characterization of our watershed, in this case, the watershed of Ribeira Brava. And in these two figures, in the left part, we have the hypsometric map, and we can see that we have big values of altitude in the blue parts, and in the other one the scene is more clear, so they are the more um, uh, 0 or 2000 260 meters of altitude. So we have a big variation of slopes. So this one is also used for determination the capacity of drainage of our river mount. Also, we make the correct classification of Strahler to determine the number of different types of streams in our watershed. So with this one, with the characterization of the watershed, with the help of the software ArcGIS, and also with the values of the precipitation, I can determine the flow, so the peak flow rate with different methodologies, Forti, Rational, Giandotti, and Mocus. And with this one, I can apply the different methods to determine the detention basin sizing, and I can check if the length of our mainstream it's okay or no to make a correct implementation of the detention basin. Okay, and also you can see in the right part I have determined the fill rate for different methodologies, rational, Giandotti, and Mocos, and also all the precipitation are uh, uh, more didn't are more more big than 85%, so they are okay. and we can make this application in our mainstream in the watershed of Ribeira Brava. So some discussion, as the study's main goals are to check it was needed to put into action flood mitigation measures to further prevent major impacts in Ribeira Brava's watershed, to use of adaptation based reveal itself as a valid and useful structural measure towards controlling its river mount's flow rate. At first, the fill rate was 94, 99, and 93% respectively for rational, Giandotti, and Mocus methodologies, which ultimately rise to only 66, 56 after adopting the detention basing measure. This structural measure outcome is clear evidence that it may enable the riverman to work below 85% of its full capacity. Moreover, to proves the accuracy of the Regional Directory of Territorial Management and Environment prediction, and it was not made any change of the stream's across section, namely its height and width. The only variable parameter was its length. It was based on this concept that the Dutch method present an abnormal oversize of the datation basin length when compared to the watershed main watercourse length. Therefore, according to this method, it will be needed to change one or both cross-section dimensions, and so it cannot be considered valid for the affirmation urban design settings. The exact same conditions were imposed for the STHD method, with it showing a different and this time valid approach, since the detention basing length was shorter than the watershed main watercourse length. So, all our work is to develop a solution we can input in our mainstream and detention basing sizing, but we have two big limitations. One is the cross section, height and width is not possible to modify because this mainstream, the most part of this mainstream is inside the urban part of the municipality, so it's not possible to make modification in the cross section, and we have only the possibility to check the length, and the length of the detention basin need to be shorter than the length of the main watercourse of the watershed. So with the HT's method, we can do this solution and we can input this one in our municipality of Ribeira Brava. Also, I can present some conclusions, and you can see the precipitation modulation in the expected rainfall from Ribeira Brava watershed in the right part of the slide. With this value, we can determine our flow rate for the different methodologies. So this table will read home full from Ribeira Brava watershed is in the event of extreme rainfall occurrence, and it was already predicted by DROTA home flood risk report. The watershed drainage capacity is likely decreased by the presence of abundant vegetation and a huge number of sediments throughout the watercourse, resulting in a lower flow rate in an already low slope stream and riverman. So also, we need to check this problem because we have some solid parts inside our mainstream, so we need to have this type of problem in attention to develop our solution. After all, this study leaves a clear open door to others that may complement its contents and methodologies by optimizing its techniques. To improve the often complex urban hydraulic system and demand, it is also expected that new studies take notice of the need to reduce sediment deposition, and it seems to make a long-term impact over the watercourse's drainage capacity and ultimately to prevent a major flood impact. On the other hand, mechanical abrasion of these streams, walls, and the amount of time that often takes to local public authorities to perform any type of maintenance have been two strong reasons for how degraded the main course tributaries are, and subsequently by the lower water quality discharged, and therefore also needed to be studied and improved. Also, we have this problem. Normally, the authorities of the Madeira Island didn't make any type of maintenance, and the walls of concrete will be in not good conditions year by year. And also, we have some waters that uh, they are aggressive, and the walls of concrete have some problems with the relation with the flow of this type of waters. So these problems need to be solved in the next further in the next years to obtain more good condition for our inhabitants in Madeira. So for my part, I end the presentation of this work. Mm, You can check in this QR code all my works and all my information if you want. If you have some questions or some things to clarify, you can send me. Also, you can obtain my email in this QR code and I will answer all of you. Thank you for your time and your attention. Okay, I will close this one. I will share all my screen if possible.
Okay, thank you. Thank you, Dr. Sergio. Any question, any feedback? Now is the
Okay.
look,
Also,
please,
Professor,
please.
if you give me some time.
Oh, okay, okay, okay.
Okay, I have put in my right part of my screen the presentation. I sent the presentation to Professor today in the morning. If you want to share with all students, it's possible. Also, when I developed this presentation, before that, I make this article in MDPI in the Journal of Water with my colleagues. So also, I have everything is published. You can check all the information. If you want, I can share this article in the chat and you can check all the information to develop this one in other location of the world if possible. So it's a big work, but it's not impossible to do. So you can develop this type of work for other location in the world. Okay, I will share if you want in the chat. Mm,
Okay, so any question, any feedback, or any clarification, please, please speak.
So now, if you want, Professor, and our participants can make the download of the file of the article in the chat.
Yes, yes.
I think that is correct, and you can make the download. It's okay, Professor?
Yes, it is fine. And yesterday's lecture is already placed, already put on Unit 1.1. So
Yes,
anybody
today.
wants to access yesterday's lecture and your this paper which you have shared, they are all on 1.1.
And this one
Everybody,
is for
yes.
1.2.
For
Okay.
today,
And
today's material, including this recorded video, will be put on the 1.2 unit. So tomorrow it will be accessible and available. Thank you.
okay. And if some participants need to clarify some things and later and if they want to clarify some things after and discuss, they can send me a message or an email. I will answer. Don't worry, okay?
Yeah. Okay, if there is no comment, no question, clarification, then we can close today's session.
If someone want to put some questions, I'm available.
No,
So
no.
I'm waiting some minutes. Don't worry.
Okay, so we are closing today, and tomorrow we will be again together with another topic. Okay, thank you so much. And
Okay, thank
please,
you so much, Professor, for your invitation, and
yes,
thank
thank you.
you for
Thank
your
you,
time.
Professor. Yes, thank you, Professor Sergio. We will, yes.
Sorry, one of the participants didn't have the possibility to download the file for yesterday. So if you give me some minutes, I will share this one today also in the chat. Okay,
No,
Professor?
no, there is no need of sharing it. This person or every person can go to the portal and can open the 1.1 unit. After all, they all have to read the material there. So
Okay,
everything cannot be served to on their table, okay, or in the
okay,
play.
Professor. Don't
So
worry.
they should also do something, no?
Okay, okay, understand.
Yeah.
So
Yes.
thank you
Yes.
so much for your time. Okay, and your
Yes.
explanation.
Please. Yes.
So, so bye. We keep in touch.
Okay.
Good afternoon.